Here we go. So this is 6-1A. I'm going to break this into two sections today. So we're just going to cover the first half of the notes. The first thing we're going to talk about is something called a monomial. Do you see anything in the word monomial that makes you think, oh, that's mono? What does mono mean? Hand. Yes, it does mean hand. Mono y mano usually means like one-on-one, right? Man versus man. So think one when you think monomial, okay? Here is what a monomial is. It is a number, a variable. What's a variable? What? Not a number. A letter, right? So a variable or letter, okay? So it's a number, a variable, or a product. What's a product? Multiplication. So the multiplying, the product of a number and variables. Could be plural, could be singular. Okay, so a monomial, think one term, one thing, with multiplication. So not adding separate things. That would not be a monomial. That'd be like a monomial plus another monomial. But just a monomial would be something like this. Okay, 5x is a monomial. It's a number times a letter. It's a number times a variable. Another monomial would be 3x to the second power. That's a monomial. So every time I change color, that's a new example of a monomial. 9x to the third, y to the negative fifth. Okay, that's another monomial. Yeah. Another example of a monomial would be negative 5 halves, x, y to the fourth. Okay, so we're multiplying negative 5 halves times x times y to the fourth. That's a monomial. Even though there's multiple parts to it, it is one term, if you will. Yes?
What's the fourth? Because I know the root of 3 is cubed. So.
Yeah, so we would just say to the fourth power. There's not like a cubed word for it. An expression, an equation that is to the fourth power is called a quartic. But we get into that in Algebra 2. You don't need to mess with that right now. Another example of a monomial is just negative 6 over 11. Okay, it can be a number by itself. So it doesn't have to have variables attached to it. But all of those are examples of monomials, one term. Okay. When monomials have the same variables and their exponents match up too, anyone remember what those are called? Let me give you an example, and then maybe you can tell me. If I gave 3x squared and 5x squared, what would you call those two? What? No? Like terms. Those are like terms, okay? So when they have the same variable and exponent, they're called like terms. We really like terms in Algebra 1, okay? Lots of like terms. They come in very handy. When you add or subtract monomials, so if I take a monomial and a monomial, really what you're doing is you are going to combine like terms. Okay, you're going to add the like terms or you're going to subtract the like terms and get a simpler version of whatever it was that we started with. Okay, so we're combining like terms. One very important thing, and this is where most of the confusion lies from what we do today to what we do in the next few days, okay? Right now we're talking about if we add or subtract monomials. You do not change the variables or their exponents, okay? So if I'm saying, for instance, 3x squared plus 5x squared, think of it like the x squared is apples. I'm saying 3 apples plus 5 apples is what? 8 apples, okay? The apples didn't change. So the variable didn't change when we just added them together. Essentially, we're doing the distributive property, if you will. We're saying x squared times 3 plus 5, and it becomes 8 x squareds, okay? So just combining the 3 and the 5, but keeping our x squared and x squared. So 3 apples plus 5 apples is 8 apples. 3x squareds plus 5x squareds is 8x squareds, okay? So don't turn it into x to the 4th. That's very tempting. Don't multiply your exponents. Don't add your exponents. Just leave that thing as you see it. Any questions on that? Okay, let's try a few. That's really what we're learning today, is just examples of these. So we've got lots of time to try it out on the homework, but let's start here. So it says add or subtract the following monomials. So we're saying 19x minus 24x. Anyone think they know what that should become? It's not 5x, but you're on the right track. What's 19 minus 24? Negative 5. So you get negative 5 times x. So it's like saying if you had 19 apples and you take away 24 apples, right, you have negative 5 apples. So keep that x as x, but subtract the coefficients. Remember, coefficient is the number that comes in front. So really you're just saying 19 minus 24 and then attaching your x to that. Well, 19 minus 24 is a negative 5, so you get negative 5x. Okay, so look at number 2. Negative 19k squared plus 2k squared. Not 21. Negative 19 plus 2. How would you plug this into your calculator? Because you can't plug in a k squared to your calculator.
Just 19 plus
You would plug in negative 19 plus 2. Okay, plug that into your calculator. What do you get? Negative 17, and then you just attach your k squared. Okay, so notice your variable and your exponent to your variable are not changing. You're going to leave those as is. Okay, so really you just take your coefficients and add or subtract them. Okay, look at number 3. Are these like terms?
Yeah.
They are. You have r squared on both, you have s to the 3rd on both, and you have t on both. Okay, so if that's the setup, what does this become? Negative 12 plus 4 is negative 8. So you get negative 8 r squared s to the 3rd t. Okay, combine your like terms. So take those coefficients, add them together. Negative 12 plus 4 is negative 8. And then that's what you're left with. Look at number 4. Because this one, I think, tends to throw people off a little bit. They see 27ab squared minus ab squared, and they want to tell me 27. Because they're ditching the ab squared. It's minus 1. 27ab squared minus, this is a 1ab squared, should be what? 26ab squared. Okay? Like I said before, your variables and your exponents should not change when we are adding and subtracting. So don't get rid of them. Don't rearrange them. Just combine the coefficients, and then you'll have your answer. How about number 5? Why? Yes, these are not like terms. This is AB, and that's AC, okay? If they're not like terms, you can't combine anything about it. So, first of all, note, these are not like terms. Okay, but your most simplified version of this is exactly what you see. 7AB plus 4AC. There's nothing you can do to that. That's as simple as it gets. Okay, so make sure you're checking, do I have like terms before I try to combine what I've got there. All right, how about number 6? Negative 7 CD plus 6 CD. Not negative 13. Negative 1 CD. What's another way you could write that?
Just
Negative CD. So if you like that better, you could call this a negative CD. That's fine too. Either one of those is great. I don't care which one you give me, but a negative 1 doesn't have to be written as a 1. You can leave the 1 out of it, but make sure the negative is there. Do number 8 for me. Just on your paper, not out loud right now. And then we'll chat about it in a minute. Okay, question number 1. Are they like terms? Yes, they are. M squared n to the 4th and m squared n to the 4th. So they are like terms. What do you get? It's not 0. But a lot of people want to say it's 0. What? Not 1. Negative 30. This is negative 15 minus 15. And again, use your calculator. Let your calculator do the mental math in its head. If you type in negative 15 minus 15, you should be getting a negative 30. What goes behind that? M squared n to the 4th. Okay. Questions on that? Okay, then it gets a little bit fancier when you look at things like number 9. 9 is 2y plus 14z minus 11y minus 10z. Do you have like terms? You do. Can you just combine them all? 2 plus 14 minus 11 minus 10. No, you can only combine what are like terms. So you could rewrite it. Here's where I see a lot of mistakes, okay? People see this, they go 2y, and then they see a plus after the 2y, and then they see an 11y, so they add them together. Which positive or negative, plus or minus, do you keep with a number? Yeah, it's whatever is right in front of the number that you're sticking with, okay? So those two would go together, and this is a positive 14z and a minus 10z. So just make sure that you keep those together like that. If you want to rewrite it, you totally can. It would be 2y minus 11y, and then it would be plus 14z minus 10z, okay? I don't need you to do that step for me. If you see it on your own without having to rewrite it in the order of like terms, that's fine. But if it helps you to lay it out with your y's together and your z's together, then do it. It's one more extra step. It's not a huge deal to write that out. What does this become? 2y minus 11y. Remember, in your calculator, you could type in 2 minus 11. What do you get? Negative 9 times y. Keep your variable. And what do you get for 14z minus 10z? It's a 4z. What operation is happening? Are we adding or subtracting that? Well, it's positive, right?
It's positive
14 minus 10 is a positive 4z. So this would be plus 4z. Okay, so this is your most simple answer. Don't combine that. That is not negative 5yz. Okay, if they're not like terms, we cannot put them together. All right, see what you can do with number 10. Do you have any like terms on this one?
Yeah.
You do. What are they?
16s and -17.
Yes, 16s and -17s. So if you want to rewrite it, you can. Typically, when there's variables involved, they will put them in alphabetical order. So if you were going to rewrite this, they would probably rewrite it 8r plus 16s minus 17s. Sanaya, did you want to give me the answer? Wait till we're done with this. We're close. What do you get from this? The 8r is going to stay. What does this become? Minus 1s. So you could just write it as minus s. If you want to put the 1 in there, that's fine. The other answer you could have gotten, and I would totally take it, is if you told me negative s plus 8r. Okay, that's the same thing. They're just in a different order. What I won't take is s minus 8r. That's different, right? The minus has to stay with the s. The positive has to stay with the 8r. Does that make sense? So this is okay. This is not. Okay? Yeah.
I got -1s plus 8r.
That's fine too. Yeah, if you want to put the 1 in, that's perfectly good. Okay, 11 and 12, and then we'll be done. Do you have, what? Yeah. Do you have like terms on number 11? Yes, you have v squared and you have v. Okay, so keep the v squareds together. Keep the v's together. What do you get for your v squared? 13 v squared. So 11v squared plus 2v squared will be 13v squared. And then what?
And then it's -16.
Not 16. So you have 7v minus 32v. What?
I put -23, not 32.
Oh, gotcha.
Yeah.
What does that become?
An angle.
Is it positive or negative? 7v minus 32v. It's going to be negative, right? So you just type in 7 minus 32
-25v.
is a negative 25 times v. Okay? And again, if you would prefer to rewrite it, go ahead and rewrite it. That's great. Okay, number 12. You gotta be a little bit careful on this one. Why do you suppose I say that? Almost identical. One is a squared b, the other is ab squared. Are those like terms? No. So you got to find the ones that are like terms and combine those, but don't put the other piece with it. What does this simplify to? 8a squared b. So if I subtract these, 9 minus, this would be a 1, right? So that's 8a squared b. And then plus the other part, 5ab squared. And I know they look a lot alike. You cannot combine that, okay? They don't have the same exponents attached to the same variables. So unless they're identical, you can't combine. Questions on any of that?